Welcome to the Chapter 3.2 lesson video. We're going to talk about adding, subtracting, and multiplying polynomials today. So I'd take our notebook out. This should be a quick and refreshing lesson on stuff you're already familiar with, but we want to recap it and refresh on it since you probably haven't done it in a while. All right, so today we're going to talk about how we can add, subtract, and multiply polynomials. There was something else that we normally do called binomial expansion theorem, which you can look into if you are interested, but we are not going to cover it this year. Like terms are constant terms, or constant numbers, terms, or which are variables that have exactly the same variables to the exactly the same powers. So some examples of things that are like terms, are things like 2x and negative 5x. These are like terms. 11 and 75 are like terms. They're both constants. 3xy cubed and 10xy cubed are like terms. They have exactly the same variables to exactly the same powers, or they're just constants, things without variables at all. Things are not like terms, but often confused for like terms. So these are things that are not like terms, but often confused for like terms, are things like 2x and 5x squared. We cannot combine those together. Other things that are often confused as like terms are maybe x and y, like 5x and 2y. Even though they both have variables, they are not variables to the same power. You also have to be careful about when variables have a combination of powers, something like 3xy squared and let's say 5x squared y. So they're very similar, but they're not quite exactly the same. And so we can't really do anything to combine them together. All right, so when it comes to adding polynomials, that's really all we're doing. We're just adding together, combining like terms. So the best way I have ever found to combine like terms is really just a method where you underline things with matching variables to matching powers. So for example, I'll look in this first parentheses here and I'll say underline this with just like a straight underline, and I'll say x squared, and then I'll look through the next polynomial. I'll see if there's any other x squareds, and oh, there we go, there's another thing with x squareds. All right, I have this negative 3, that's a constant, so I'll use a little squiggle line underneath it. I'll look through, see if there's any other, there's an 8, that also is a constant, so I'll put a squiggle line underneath it. And then last but not least, we have this 2x cubed, which I'll put a little loop-de-loop underneath. It has no like terms, so it's not going to get combined, if anything. We write our answers in what's called standard form, so highest degree or highest exponential power to lowest. So 2x cubed is going to get the first location, 2x cubed. We're then just going to add the coefficients of the things that are like terms. So we have negative 7x squared, and then this is a positive 1x squared. So negative 7 plus 1 is negative 6x squared. All right, and then we're going to add our constants together. Same idea, positive 8 and negative 3 together make positive 5. So this is adding polynomials together, something you should be comfortable with. We've done it for a couple years now, and it's just combining the coefficients of things that are like terms. All right, so if we wanted to find the perimeter of something like this, and it's given in all these variables, what we're going to do is we're going to combine all the like terms together. So I'll go through and I'll underline. This is 5x, this is 2x, this is 6x, and this is 2x. Those are all different forms of x's. We have a constant of 3, a constant of 4, and a constant of negative 1. Combine all your x's together. So you had 5 plus 2 is 7, plus 6 is 13, plus 2 is 15x, and then you had a 3 plus 4 is 7, minus 1 is 6. So 15x plus 6 is the perimeter of this polygon. Continuing on, subtraction is a very similar idea, except what we do for subtraction is we really have to distribute this negative. This is really one way to think about this. This is a negative 1 times this parentheses. So we have to distribute that negative to everything on the inside there. Now, what I do to do that is I personally don't like the distribution. I sometimes forget what I'm doing. What I like to do is I like to think of subtraction as addition of the opposite. So what I'm going to do is I'm going to change my subtraction sign to an addition sign. And then I'm going to change all the other signs to be opposite. So this was a positive 2a squared. It's now a negative 2a squared. This was a negative 7b squared. It's now a positive 7b squared. And this was a positive 5. It is now plus negative 5. So what I did is I changed this sign in between the parentheses to be the addition instead of subtraction, and then every other term after it in that parentheses after the negative became opposite, because that's what would happen if we distributed that negative. We can now just go through and combine our like terms like we did on the other piece. So we have the a squareds, we have these constants, and then we have this b squared that doesn't have a like term. So we'll go ahead and combine them together. 6a squared minus 2a squared is 4a squared. Then we have the plus 7b squared that we remembered to distribute that negative to. And then we have the 20 minus 5 is 15. So that is subtracting polynomials. All right. Lastly, we're going to start talking about multiplying. So we'll start with multiplying the simplest thing possible, which is multiplying a monomial, things that are one term, with another thing that is one term. When we multiply a monomial times a monomial, things with no addition and subtraction, we just multiply the different things that have the same base. So we're going to multiply the constant with the constant, the x piece with the x piece, the y piece with the y piece. So I'm going to write this a little bit differently. What I'm going to do to write this is I'm going to multiply it out. So 3 times 4 is multiplying the constant times the constant. And then times, we're going to have the x piece. The x to the fourth, I'm going to rewrite that as 4x's. X, 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 x. The x to the fifth, I'm going to rewrite that as 5x's. So that's x, 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 because that's what x to the fifth and x to the fourth really mean. The y, I'm just going to rewrite as a y, because it was a y to the first. And then the y to the third, I'm going to rewrite as y, y, y. All right, you can now kind of see how this is going to work. I can now multiply together all the pieces that are together. 3 times 4 is going to make a 12. I had an x to the fourth. I had an x to the fifth, but now I have 9 x's. X times x 9 times, so that's going to be x to the 9th. And you can ask yourself, how did I get from 4 and 5 to 9? I added them, 4 plus 5. So when we multiply with the same base, we add those exponents. That's x to the 9th. Same thing with the y's. This was really y to the first times y to the third. 1 plus 3, we had 4 y's. Left over when we multiplied them together. So we write y to the fourth. All right, so that's multiplying monomials. When we multiply coefficients, we just multiply them like normal numbers. When we multiply variables with the same base, we add the exponents. All right, so when we multiply polynomials, however many terms times however many terms, we're going to distribute. So everything in one polynomial has to get multiplied by everything in the other polynomial. This is the distribution method of doing things. We'll talk about one other method here in a second, but this is the distribution method of doing things where we distribute the first term to everything and then distribute the second term to everything. There's 2 in this one and 3 in this one, so we have 2 times 3, we have 6 problems, really. So let's go ahead and write out what those 6 answers would be. Our first answer is x times x squared, which is x to the third. Then x times negative 2x is negative 2x squared. Then x times 3 is positive 3x. Then we distribute the 5. 5 times x squared is positive 5x squared. Then 5 times negative 2x is negative 10x. And then 5 times 3 is 15. So we just distributed each piece times each piece. I did x times x squared, x times negative 2x, x times positive 3, 5 times x squared, 5 times negative 2x, and 5 times positive 3. I can now go through, combine my like terms to get my final answer. I have just an x cubed. I have negative 2 and positive 5x squared, so that makes positive 3x squareds. I have 3x and negative 10x, that makes negative 7x. And then I have just a positive 15 by itself, and that is our final answer. All right, the other way to go about this problem is to use kind of this graphic organizer method. What we do is we take the number of terms in each polynomial and we make that many columns by that many rows. It doesn't really matter which one is which. I usually make the first one your rows and the second one your columns. You go ahead and you write the terms one per row. So this would be x and this would be 5, positive 5. And then you write the terms of the other one in the other row. So this would be x squared, this would be minus 2x, and this would be positive 3. This is just a graphic organizer. It just helps you recognize what's being multiplied by what in each place, keep track of everything that's been multiplied, so that way you don't forget something. X times x squared was x to the third still. This is negative 2x squared still. This is positive 3x still. This is 5x squared still. This is negative 10x. This is positive 15. We can then combine our like terms. We had an x cubed. We had the 5x squared and the negative 2x squared, which we said was 3x squared. We had the negative 10x and the positive 3x, which was negative 7x. And we had the positive 15 on the end. Same answer, just a slightly different way of organizing them. I really like this method when we get to like 2 by 3 or 3 by 3 polynomials. If it's just a 2 by 2, I usually just distribute it out. But a 2 by 3 or anything bigger than that, really, I like this method because it helps me make sure I do all the different multiplications and add them all together. All right, the last little multiplying thing I want to review is just a couple special patterns. So if you ever have this pattern happen where it's the same terms, the exact same terms, just one has a plus and one has a minus, then your answer when you multiply them will just be the first thing squared minus the second thing squared. So here we have a 3x plus 4 and a 3x minus 4. Exact same thing, just one has a plus and one has a minus. So our answer here is going to be 3x squared minus 4 squared. And so we can kind of expand that out. 3x squared, that's 3x times 3x. That's going to be 9x squared. And 4 squared is going to be 16. This is the opposite of our difference of squares factoring pattern. All right, the second one we have here is the perfect square binomial pattern. And if we have an a plus or minus b squared, so if it's plus or minus, that determines the plus or minus in your answer over here. Your answer is just going to be the first thing squared. And then if it was a plus, it matches with a plus. If it was a minus, it matches with a minus. Plus or minus 2 times the first and the last term, plus the last term squared. So in our example right here, we have a minus sign, so we know we'll have a minus sign in our answer. So what we're going to get is we're going to get the first thing squared, so x squared, and then we said it would be a minus 2 times the first thing times the last thing, and then it's always plus the last thing squared, so that's plus negative 3 squared. So we go ahead and we simplify this out a little bit. That's going to be x squared. Negative 2 times x times 3 is negative 6x. And then negative 3 squared is positive 9. So you can just multiply these like normal. There's nothing stopping you from distributing them out. But if you memorize these patterns, if you want to take this one and just keep it simple and rewrite it for yourself as x minus 3 times x minus 3 and then distribute it, that's totally fine. Nothing wrong with doing that. It's just there's a little pattern here, and if you recognize the pattern, you can do things a little bit faster sometimes. All right, with that, you should have enough information to be able to get started on the assignment. If you have any questions, please reach out to me. Otherwise, I'll see you in our next session. And until then, I hope you have a great day.